Welcome. In this video, I'll be talking about data center redundancy. Let's start by talking about availability in data centers. The availability of a data center is simply the total time that a particular service is available divided by the total time in a year. As an example, if you have a service that requires 30 minutes of maintenance per month, then plugging in the numbers in the formula will give you the availability percentage, which is about 99.931% in a year. Conversely, the downtime of a service, if you are given the availability percentage, is nothing but the 1 minus the availability in a year times the total time in a year. So if you have a data center that claims to be 99.995% available, then the total downtime in a year for that data center should not be more than 26.3 minutes. So let's look at redundant components and the ways in which a data center can increase its availability. So first, at servers can be built with redundant components. So you can have redundant or power supplies which allow a server to take two power feeds simultaneously, allowing the data center operators to replace any one power supply if it fails. The same can be said with other components such as network interface cards or even RAID arrays. So using RAID, disk failures can be tolerated. They are probably the number one component that fails in servers, especially at scale. Next, we have power. So we can have dual feed systems designed in the data center where you have multiple power feeds possibly coming from different power sources that are used to feed power into the various IT components in the system. In addition, most data centers have some sort of UPS in case there is a power failure, and the UPS will last long enough so that the data center can switch to a generator backup system. As far as cooling is concerned, many data centers are designed to have multiple computer room air conditioning units. In case one or more failed, they would still be able to keep the data center active. As well as in networking, there are topologies which allow use of redundant switches. So in case a switch fails, the data center is still active and running. Many data centers also use multiple connectivity providers to provide a basic level of connectivity in case the main ISP that is connected to the data center fails. So based on their design and their ability to resist failure, data centers can be classified into different tiers according to the TIA 942 standard. So the first or basic tier in data centers is tier 1. This is a basic data center that is non-redundant, which have single point of failures. Fairly significant amount of downtime can be expected. In tier 2, the data center is designed with redundant components. So you may have a single path of power or electricity or cooling, but there are some redundancies built into the path which allow for safeguards against unplanned outage. In tier 3, there are multiple concurrently maintainable paths for power and cooling which allow these components to be serviced without having any downtime in the data center. And in tier 4, you have a fault tolerant data center which can experience a unplanned outage but will still be able to run at full capacity. Now this is the one which has the least amount of downtime and the most availability of all of the tiers. Okay, so let's look at their specifications. The basic data center tier requires an availability percentage of 99.671. So that's approximately 28 to 29 hours of downtime a year. In tier 2, that's brought down to about 22 hours and 41 minutes. And in tier 3, the downtime must be less than 1.5 hours a year. So that's a highly reliable data center. And in comparison, a fault-tolerant data center should not have a downtime of more than 26.3 minutes per year for it to be officially classified as a tier 4 data center. As you can imagine, data centers that are higher in the tier classification are much more expensive to build, maintain, and operate. And you will see tier 4 data centers being used for critical systems for various organizations, since they have a very high requirement in terms of availability and downtime.